All right, this is part 2 of your chapter 10 review. Number 12, if line segments DE, EF, and FD are tangent to circle A, find the length of EF. So we know that whenever two tangent lines intersect, the distance they each are from, or the distance of their point of intersection from where they touch the circle is congruent. So this side is 4 foot and this side is 4 foot. These are congruent. And then we know that this guy's 2 foot, so this guy has to be 2 foot. And then lastly here, this is 9 foot long. If this side is 4 foot, we know this side has to be 5 foot. So I'm gonna mark this guy, 1, 2, 3, that's 5, which means this guy is also 5. And the question was find the length of EF. Here is EF. It's made up of 2 feet plus 5 feet, which is 7 feet. Okay, hopefully that made sense. Number 13, circle A has its center at 5, 7, and CB is tangent to circle A at B, B 2, 8. Find the slope of CB. So we need to draw this out to kind of see what they're talking about. All right, so we've got our circle, and this is circle A. So here's point A. And this is at 0.57. So let's say, I'm going to kind of draw a little coordinate plane here. This is over 5, up 7. It's not exact, but it's supposed to be. Okay, so here's point A at 5.7. And then it says line CB is tangent to A at point B, 2, 8. So B is touching circle A. We'll say right about maybe here-ish. Let's say that's point B. And this is supposed to be over 2, up 8, right? And it's a line. Find the slope of CB. It's a line tangent to A, so we know it's going to do something like this, right? It's tangent at point B. And we know that the distance from B to A here, this guy is perpendicular. So the slope of this line, somewhere there's point C, somewhere on the line, we don't know where. We know this whole line CB touches the circle at point B, and we know that the radius of the circle is perpendicular to the tangent line at the point of tangency, which means this is 90 degrees. So if we can figure out the slope of this line, B to A, and we have both points, A is at 5.7, B is at 2.8, so we can figure out the slope. If we know the slope of this line, it's perpendicular to the slope of the line we want. So they're just going to have opposite slopes, right? So first thing I'm going to do is find the slope of BA, or AB, y minus y over x minus x. I'm going to do 7 minus 8 over 7 minus 8 over 5 minus 2. Okay, and then when I simplify that, I get negative 1 over 3. So that's negative 1/3. So the slope of this radius of my circle is negative 1/3. That's not super important, but the radius of a circle is always perpendicular to a tangent line. So if this line and this line share point B, and this slope is negative 1/3, this slope, which is perpendicular, has to be the opposite. So the opposite means I have to flip this upside down. And if it's negative, I make it positive. I change the sign in front. So the slope of the other line here, line CB, has to be positive 3 over 1, or just 3. So our answer choices here, our slope of line CB is positive 3. The slope of BA is negative 1/3, but the slope of our line, which is tangent to our circle, is 3. Number 14, if AB is tangent to circle P at point B, find the measure of angle 1, and it gives us a picture here. Oops, this is super crooked, sorry. Here, let's zoom in a little bit. So AB is tangent. Here's this guy right here, so it touches the circle at point B. We know this arc right here is 86 degrees, right? And we also know that when we have a tangent line with a line coming off of it, the angle it creates, this little guy right here, is half the size of this big intercepted arc. So if this arc is 86, this little angle right here is 43 degrees. This guy. I also know that this line is a straight line, so these two angles together make up 180 degrees, right? So 180 degrees, the whole thing, minus just this side 43 is going to give us 137. This angle here is 137. 137 plus 43 adds up to a straight line 180. So our answer is H for that problem. I hope that made sense. All right, number 15. Find the measure of angle PQR if ray QP and ray QR are tangent to circle X. So we're finding this guy right here, okay? Remember, when we have tangent lines, we use big arc minus the little arc divided by 2 gives us our angle, right? Sorry, this is so crooked. Big arc minus little arc. Now, I know the entire circle is 360. It's only split up into 2 arcs, this 250 degree guy and this little guy. Both of these together make up the whole circle. So if this is 250, the whole thing is 360, that means this arc has to be 110. So 250 minus 110 divided by 2 is going to give us our angle measure. Big arc minus little arc divided by 2 gives us this guy. 250 minus 110 is 140. 140 divided by 2 is 70. So this is a 70 degree angle. A. Number 16. I'm trying to not drag this out for a long time. If you are confused on anything, please go back and rewatch the lesson video. And then if you're still confused, send me a message and we'll go over it together. All right, number 16, find X. So in this guy here, remember, when we have 2 intersecting chords that intersect inside a circle, we can multiply the 2 segments together, and the product should be the same for both chords, right? So 3 times X should equal 7 times 5. So I can do that over here. 3X should equal 7 times 5. 3x equals 35, divide by 3, divide by 3, and x is going to equal 35 over 3. I don't know what that is in decimal form, but that's not one of my choices. However, 35 over 3 is a choice. So I'm done. Number 17, find the length of line DE. Find the length of line DE. So I'm going to zoom in on this guy a little bit. All right, remember when we have a problem like this, we multiply the portion of the line outside the circle times the entire line, and that's equal to the portion outside the circle times the entire line. So we're looking for DE, we're gonna call it X, right? So we're gonna say, and I'm gonna use paper down here to do it. Let me scoot that up a little bit. Zoom out a little bit now. Portion of the line outside the circle, 5, times the entire line, which is 5 plus x, is equal to the portion outside the circle on the bottom, 6, times the entire line, which is 6 plus 8. Okay, so now I can solve for x with this equation. So I'm going to say, I'm going to distribute this 5, and I get 25 plus 5x equals 6 plus 18 is 14. 6 times 14 is 60, and 24 is 84. I'm going to subtract 25 from both sides. 5x equals 64.59 divided by 5, divided by 5. X equals 59 over 5, so I might have to, excuse me, I might have to change that to a decimal. But first, I'm going to take a look at my answer choices and see if this is any of my answer choices. 59 over 5. So here's my answer choices. Ha-ha! Right there. Okay, number 18. Find the center of the circle whose equation is x plus 15 squared plus y minus 20 squared equals 100. So remember, for the equation of a circle that's less than 10, 8, if you haven't watched it yet, please go back and watch it. It's important. We're going to look at this guy and this guy and this guy, okay? In our equation of a circle, x minus h squared plus y minus k squared equals the radius squared. The important pieces are h and k. hk is the center of our circle, and this whole thing, r squared, that's our radius squared. Right, so here it says find the center of the circle. We don't care about the radius right here. The radius would be 10, by the way, because if the radius squared is 100, take the square root, r equals 10. We want to know about the center. So in the formula, we have a minus sign. The only thing that can change a minus to a plus is another minus sign. So this number has to be negative. So this is a negative 15. And then this number over here, in the formula, it's negative, so k is just positive 20. So the center of our circle is at negative 15, positive 20, just based off of these two things. Negative 15, positive 20 is this guy right here. Okay? Number 19, find the equation of a circle whose center is at negative 1, 5, and radius is 8. So when we write that out ourselves, we write x minus negative 1 squared plus y minus 5 squared equals 8 squared. And then when we simplify that, we get a plus sign here, and 8 squared turns into 64. So we need x plus 1 squared, y minus 5 squared equals 64. Okay, these are both out because they're x minus 1. We need x plus 1 since 1 is negative, so it changes our formula. So we've got x plus 1 squared, x plus 1 squared. All this matches so far. This equals 8, this equals 64. In our formula, it equals r squared. Radius is 8, 8 squared is 64. So our answer is D. Okay, and then number 20, we've got a bonus, but we're almost done. All right, find the equation of circle P. So first of all, the center is at negative 1, 2, 3, 4, positive 2. Negative 4, positive 2. And the radius from the center to the outside is 3 units, right? So we're going to have x minus negative 4 squared plus y minus 2 squared equals 3 squared, which is 9. So x plus 4, y minus 2, 9. X plus 4, these two are out. Y minus 2 equals 9, this guy. Okay, as long as you have that formula written in front of you and you understand this second number, and the radius squared, equations of circles are super simple. All right, and for the bonus, is the point, negative 3, negative 5, inside, outside, or on the circle whose equation is blah, 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 blah. Okay, so we want to figure this out. So our center of our circle is going to be at negative 7, comma 2. And the radius of our circle is square root of 62, which we're going to have to change to a decimal. 7.87, we'll say, is about 7.87. Okay, so if we were to graph this, let me get a piece of paper here. If I was to graph this, boom, negative 7, comma 2 with a radius of 7.87. Negative 1, 2, 3, 4, 5, 6, 7, up 1, 2. So here's the center of my circle. And the radius is 7.87. When we sketch our circle, we want to kind of go up 7.87, down 7.87, this way and this way. And then we can kind of sketch our circle, right? So it's going to be slightly past this guy. It's going to go up. We're already up 2. We're going up 7.8. So it's going to be all the way almost to 10, right? It's going to go backwards. We're already 7. We're going to go back 7.87 more. So we're going to be backwards about almost negative 15, right? And we're up 2. We need to go down 7.87. So we're going to be down almost to negative 6. Let me back up a little bit. So when we sketch our circle, Those are kind of our oops, that was a really crappy sketch of a circle. Those are that's so bad. Woo! Okay, well, you know what we're supposed to be doing. Okay, so the question was, is point -3, -5 inside, outside, or on the circle? So if I went backwards, 1, 2, 3, down 1, 2, 3, 4, 5, 1, 2, 3, down 5 about here. It looks like it might be on the circle. All right, let's plug it in and see. If it's on the circle, it should be a solution to our circle. So if we plugged in this for x and this for y, does it solve? -3 plus 7 squared plus -5 minus 2 squared. -3 plus 7 is 4. 4 squared is 16. -5 minus 2 is 7. 7 squared is 49. 62. 16 plus 49 is 55. So it's not quite, it's not on the line. And the way we sketched here, I guess the next thing we can do is find the distance from these 2 points. The distance from the center of our circle to that point, and see if it's bigger than 7.87 or less than 7.87. We know the point can't lie on the line because it doesn't solve the line. These are not equal. So now we want to figure out if the distance from the center of our circle to this point, and the center of our circle is here, so the distance from this point to this point is more than 7.87 or less than 7.87. So distance equals square root of x minus x squared, so -3 minus -7 squared, plus y minus y squared, -5 minus 2 squared, all under the radical sign. So when I simplify, -3 plus 7 is 4 squared. Oh, we already did all this. Plus -49, that's 16, that's 55. What do we say? 65, not 62, sorry. 65, not 62. Square root of 65 is 8.06. Okay, so that's bigger than 7.87, which is our radius, right? So if we're looking at this guy, here's our radius. It's a really crappy circle, I know, but if here's our radius, the distance from here to here, a point on the line is 7.87, but our point is a little bit further than that, right? It's 8.06. So this is outside of the circle. It's further away than what the radius length is. So with our point, -3, -5, what is it? -3, -5 is outside of our circle. So we're just going to say outside. All right, if you guys have any questions at all, please let me know.